This video is going to be the first in a series on the mechanics of the vibrating shuttle sewing machine, showing some of the very many and varied methods of achieving the exact same functional mechanism using different combinations of action. So what we'll be looking at is machines that use a vibrating shuttle, such as this machine here, and you can hear me digging through the drawers. I'm looking for the shuttle for this machine. Many manufacturers produced a machine that used a bullet-shaped shuttle which vibrated back and forth to produce the lock stitch in an action that is not much different than that of a weaving loom. The real interesting thing is each manufacturer had its own mechanism for achieving these actions. And we're going to start this series off by looking at what is probably the most interesting, and that is the mechanism used by the Free Sewing Machine Company of Rockford, Illinois, whose machine is shown here with the Elgin label on it, and the circumstances by which the Elgin name was applied to this machine is unknown. It does have a very interesting craftsman style cabinet that is very unique, undoubtedly capitalizing on the popularity of the craftsman style of the time. Most free sewing machine cabinets that I've seen are the more gingerbread styled cabinets that are mechanically identical to this. This is an automatic drop head machine where the head lowers down automatically when the top is lifted. It's interesting that many of the sewing machine companies made automatic drop head cabinets. Singer seems to have only made such niceties in their fancier cabinets, such as the drawing room cabinets, but it was very commonplace for most other manufacturers to make automatic drop head cabinets. Anyway, this video, the purpose of this video isn't on the to focus on the cabinets or other details. It's the focus on the mechanics of the machine, which on this machine is somewhat unusual. And I will tip the machine back and show how this mechanism works. First step being to make sure that the belt is derailed, and then pressing this button here, the machine will tip back. It's probably going to require both hands to do this. Now, initially upon inspection of this machine, you'd expect something similar to the Singer 27 or 127 mechanism, but in fact what we find is a modified rotary sewing machine mechanism. This drive was first made by Wheeler & Wilson and then widely copied by the White Sewing Machine Company, and it uses a crank and connecting rod on the top main shaft to produce a rotary motion with another crank and a sliding block on the bottom main shaft. And you can see what's going on there. The connecting rod has a sliding block somewhere in the middle of the arm, probably near where this unmachined boss is for mounting a hand crank or an electric motor. And you can see that this sliding block is needed because the end of that connecting rod does not trace a perfect circle, and as a result this lay shaft at the bottom will alternately speed up and slow down. This mechanism is derived directly from a rotary sewing machine action using a rotary hook and bobbin. And then here we see a sliding block being used to achieve the forward and back motion of the 4-motion feed. And it's unlike a lot of other machines, it's instantly reversible. I'm not reversible, but the stitch length is instantly changeable by loosening the clamp screw and moving this to any desired angle. It works just like the valve link motion on a radial valve gear on a steam engine, where there's full gear ahead. Now it's tracing that angled path causes it to move this shaft back and forth, and that produces a back and forth motion of the feed dogs. And then turning it back vertical again causes that lever to simply move up and down without producing any useful motion out of that shaft. And that's connected directly to the, oh boy, what have we got here? This is probably the most unusual part of this mechanism, and it's amazing to see the machine work that was done on this and think that they could have done this back then. In fact, this was a matter of routine. And you look at it and you see how precisely it's machined. It's an amazing piece of engineering. But this toggle action, for lack of a better description, is what produces the vibrating motion of our shuttle carrier there. And it's derived from this lower lay shaft here that's driven by this connecting rod and sliding block assembly. And then of course a dwell cam here at the other end produces the fixed up and down motion of the feed dogs for producing the 4-motion stitch. But the action of this is just absolutely amazing. And look at the gap there at either end of that and how steady it is. I don't know what the tolerances would need to be for something like this, but it must be quite tight. I mean, it's absolutely effortless to turn this. Watching it, the action can be somewhat mesmerizing, even at speed. Apart from these, the mechanism is entirely conventional. There is one more interesting point worth mentioning on this machine that I have not seen on any competitors' makes, and that is the mechanism which operates the needle bar. And on all shuttle type sewing machines, the needle bar has to do sort of a double take at the bottom of its stroke. This is part of the stitch forming process. So it raises, lowers, does a double take, and then goes up. On most machines like this is done by using a Scotch yoke drive, where instead of the slot of the Scotch yoke being straight across, it has a V shape mounted in the head. In fact, that's why the heads of sewing machines are shaped the way they are, is to provide a very wide area for the needle bar to have bearing on, plus room for the Scotch yoke mechanism. But if we look at the inside of this machine, you will not find a Scotch yoke. You will find instead a rather ingenious arrangement of connecting rods, which in conjunction with the take-up produces the action. And I'm sorry if the lighting is poor here. But I'll zoom in on this. So as you can see, the take-up lever has a connecting rod which is connected to the crank pin of the drive, and then a tail on this lever connects to a pin which the connecting link for the needle bar attaches to. And there we're at the top of the stroke. It comes down, and there's where it does the double take, where that simply rocks back and forth. So without any sliding blocks and Scotch yokes, it produces the up and down motion with the double take at the bottom of the stroke in a much more efficient manner, and it's probably more robustly built too. So a very interesting machine, the Free Sewing Machine Company of Rockford, Illinois, and a very efficiently made Singer 127 clone, which is in reality has quite a few refinements of its own that really, when you look at the mechanism, makes it a much superior machine to the Singer. But Singer's massive marketing network assured their virtual dominance. So I hope you enjoyed watching this. Like I said, this will be the first in a series of videos on sewing machine mechanics. And this is Oklahoma Bridges signing out.